Hello. Hello and welcome to the Studify Plus. We are in the discussion of two port network और इस डिस्कशन में हमने कल बात की थी कि कैसे आप Z पैरामीटर्स को एनालाइज करते हैं और अगर आपका नेटवर्क प्योर रेजिस्टिव नेटवर्क है तो देयर इज नो नीड टू फाइंड द बोथ द रेसिप्रोकल पैरामीटर्स फॉर अ रेजिस्टिव नेटवर्क रेसिप्रोकल पैरामीटर्स आर सेम. How you can connect the Z parameter, and that thing is known as the series connection of Z parameter. Yesterday we had the discussion on this topic also. Now we have started the discussion on Y parameter. So this is, you can say, the Z inverse approach to analyze the two port network. In this approach the independent variables are voltages, and in Z parameter independent variables are current. So we have talked about it. और इस चीज का आप ध्यान रखें कि जो क्वांटिटी डिपेंडेंट वेरिएबल है वो है वोल्ट मीटर और एमीटर की रीडिंग्स, और जब मैं बोलता हूं कि कुछ मेरे पास इंडिपेंडेंट वेरिएबल है वो है सप्लाई, तो दोनों को ध्यान रखें. V1 और V2 का नेचर अलग अलग है. एक वोल्ट मीटर की रीडिंग है और एक सोर्स का काम कर रहा है, पर रिप्रेजेंटेड बोथ आर रिप्रेजेंटेड बाय V1 एंड V2, I1 एंड I2. फिर हमने देखा कि जो डायरेक्शन ऑफ करंट है दैट इज इनसाइड द पोर्ट. तो और कल हमने बात की थी वाई पैरामीटर के बारे में. तो वाई पैरामीटर के बारे में हम देखेंगे कि व्हाट इज द सीरीज एंड व्हाट इज द कनेक्शन, हाउ यू कैन कनेक्ट द वाई पैरामीटर टू गेट द एडिटिव इफेक्ट. we'll talk about that point, and we will solve few more previous year questions based on Y parameter. So let's start with this. So yesterday we have talked about Y parameter. So let's start. Y parameters, or these parameters are also known as admittance parameter. Y parameter, and how we have what is the inverse of Z parameter? This is I1, I2. This variable is represented as, these variables are represented as Y11, Y12, Y21 and Y22. What is next? And yesterday I have told you to analyze the Y parameter. What is the best strategy to convert, if your resistor or capacitive network, convert that network into the delta shape so that you can get easily Y parameter directly you can obtain. This is V1 and V2. What you have to keep in mind, that V1 and V2 are your supplies and I1 and I2 are dependent variable. These are the readings of emitter. So keep this thing in mind. Or you can say, how I can write I1? I can write I1 like this. I1 can be written as Y11 V1 plus just multiplication of, this is 2 cross 2 matrix, this is 2 cross 1, so you will get one matrix. Y11 into V1 plus Y12 into V2. This is equation number 1 we can obtain from this multiplication, and the value of I2 can be linear combination of equation. Y2 is this Y21 V1 plus Y22 V2. Correct? We have talked about this two equation, and we have talked about I1 V1, I2 V2, and the ratio Y11, Y12, Y21 and Y22. We have talked about this ratio. Let's go to little further and let's try to get the series and parallel connection of, and yesterday we have also talked about two conditions. The condition for a reciprocal Y network. A network will be a reciprocal Y network if Y12 is equivalent to Y21. And always remember, as I have told you, the reciprocity condition is always satisfied. The reciprocity condition is always satisfied when your network is a resistive network. In case of dependent source, you have to check. And there is a condition for symmetrical network. So can I say condition for symmetrical network? Condition for symmetrical two port from Y parameter. From which point of view? From Y parameter is given by Y11 should be equivalent to Y22. A very important concept. Very important concept. Now let's talk about one more thing, and that is known as the connection of Y parameter. Let's talk about the connection of how we can connect Y parameter. So connection of Y parameter looks like this. Suppose you are having one Y parameter here, one two-port network. This is one two-port network. 1 and 2. हमारे पास दो टू पोर्ट नेटवर्क हैं और दोनों टू पोर्ट नेटवर्क को मैं कनेक्ट करने की कोशिश करता हूं इन पैरेलल फैशन. आप जानते हैं पैरेलल फैशन में क्या होगा कि अगर वो इंपीडेंस होता तो 1/Z1 प्लस 1/Z2 हो जाता, लेकिन ये एडमिटेंस है तो कितना हो जाएगा, Y1 प्लस Y2 हो जाएगा, है ना. अभी हम इसको एनालाइज करने की कोशिश करते हैं एंड वी विल ट्राई टू मेंटेन द कंडीशन ऑफ पैरेलल कॉम्बिनेशन. तो पैरेलल कॉम्बिनेशन का कंडीशन क्या है? द कंडीशन फॉर द पैरेलल कॉम्बिनेशन कि दोनों पोर्ट जो है मेरे पास नेटवर्क हैं, दोनों के स्टार्टिंग पॉइंट भी सेम हो और दोनों के एंडिंग पॉइंट भी कैसे हो, सेम हो. जरा देखें इसको. वी आर हैविंग दिस. वन टू, ये दो टू पोर्ट नेटवर्क हैं. These are two port networks and two port Y parameters are defined for this two port network. इनके लिए क्या defined है? Y parameter defined है. So let's say I am calling first Y parameter as Y prime. I am calling my first Y parameter is a Y prime and I am calling the second Y parameter as Y double prime. Y prime and Y double prime. These are two. And what is Y prime and Y double prime? So Y prime admittance parameter for the first two port network is given by, this is given by, we are defining it. This is Y11 prime, Y12 prime, Y21 prime and Y22 prime. This is the first. And what is second? The second we are having is Y double prime. द y पैरामीटर फॉर द सेकेंड नेटवर्क, और जो सेकेंड नेटवर्क है उसके y पैरामीटर कुछ इस तरीके से दिए हैं. दिस इज y11 डबल प्राइम, y12 डबल प्राइम, y21 डबल प्राइम एंड y22 डबल प्राइम. ये मेरे पास y नेटवर्क जो मैंने y प्राइम और y डबल प्राइम को डिफाइन किया है, ये उसके पैरामीटर्स हैं जो कि दिस पैरामीटर्स आर गिवन है ना, 2, 5, 8 कुछ भी इनका वैल्यू हो सकता है, इसके बारे में हमें इंफॉर्मेशन हमारे पास है. दिस 2 पैरामीटर्स आर गिवन एंड हाउ दिस इज कनेक्टेड. दिस इज कनेक्टेड लाइक दिस, कि जो कनेक्शन है वो कुछ ऐसा है कि पहले का जो या मैं ऐसा लिख दूं इसको, लेट्स से दिस पोटेंशियल इज V1 प्राइम, और यहां से नेटवर्क में जाने वाला जो करंट है दैट करंट इज I1 प्राइम. व्हाट इज सेकेंड? दिस पोटेंशियल इज V2 प्राइम and the current which is going inside the network is I2 prime. Correct? This is our first two-port network, and for two-port network the current and voltage conditions are given. For second two-port network we can say this value is V1 double prime and current is also I1 double prime. What about the output terminal? Let's say this is your output terminal, and how you are defining the output terminal? This is V2 double prime and this current is I2 double prime. This is our we are talking about the connection of two-port networks, and in connection of two-port networks we are having this two y parameter network. For this two-port network y parameters are given. Now let's make a connection. So for parallel connection, let's say this is first the one terminal. Let's say this terminal is 1 and this is 1 prime terminal. So one terminal, and this is 2 and this is 2 prime terminal. So one terminal and 2 terminals are connected. These are connected like this. One terminal and 2 terminals are connected, and 1 prime and 2 prime terminals are also connected. So you can say one more terminal we are having here. And another terminal we are having is this. Correct? And here I am connecting my supply. So this is parallel combination. And I am calling this is a parallel combination. Correct? Let's talk about or this configuration. This configuration is known as shunt configuration, or you can say anything. Means these are two. We want to connect this to y parameter in the parallel. Then we want to connect this to or you can say we want to connect main terminal to main terminal, then we will connect reference terminal to reference terminal. All are same thing. And this value is correct? And we are having one output terminal. That output terminal is these are two output terminals. This is parallel combination of two port network, which is Y parameter is given for this network. Now what I can say, if you talk about this, for this two port, can I say the current I1 is going from away from here, I1 prime. I1 prime is the current which is going away from here, I1 prime. And I2 prime is the current which is going away from here. So can I say the net current is what? I1 double prime. So one equation I can write, and what is that equation? That the current which is going away from here, if I write this current I1, we know what is the value of I1. The value of I1 is given by I1 prime plus I1 double prime, correct? And if I write this voltage as V1, because we are talking about the equivalent of this Y parameter, so can I say this Y, if I consider the bottom terminal as reference, so reference is connected to both the two port, and V1 potential will appear here and V1 potential will appear here. So what I can say, from very basic knowledge of parallel and series voltage distribution, we can say V1 is equivalent to V1 of prime, means this voltage and this voltage is same, and this is equivalent to V1 of double prime, correct? These two equations are valid when I am writing for the equation for port number 1. Let's talk about the port number 2. What are the two equations for port number 2? So equations for the port number 2 is given by, if I write this potential as V2, can I say this potential is connected to this point, this is also V2 and this is also V2, and the bottom terminal, if I consider this as a reference, the reference is same for first terminal, first two port and second two port. So you can say first equation is V2 is equivalent to V2 of prime and V2 of double prime. While if I consider this current as I2, can I say I2 current is divided into two parts. The first portion is going into this and second portion is going into this. So can I say I2 can be written as addition of I2 prime plus I2 double prime. These are the equation from output port, and these are the equation for input port. What we want to write? We want to write the equivalent of this Y parameter configuration. So how to write the equivalent of this? For writing equivalent of this, let's write the Y parameter for the first. So I1 prime, I2 prime, this is equivalent to Y11 prime, Y12 prime, Y21 prime and Y22 prime. This much times of, because we are writing the Y parameter for the first network, and first network I1 dash, I1 prime and I2 primes are current, and V1 prime and V2 primes are voltages. So can I say, here I can write this voltage as V1 prime, this voltage as V2 prime, correct? This is our first Y parameter for the first network. What is Y parameter for the second network? So you can say the Y parameter for the second network will looks like this. We are writing these parameters independently. So Y parameter for the second network. So for second network the voltage is V1 double dash and V2 double dash. और जो यहाँ हमें करंट मिलेगा वो मिलेगा I1 double dash और I2 double dash. So I can write I1 double prime, I2 double prime, Y parameter for the second network is written as Y11 double prime, Y12 double prime, Y21 double prime, Y22 double prime, and this is multiplied by V1 double prime and V2 double prime. This is the idea. Now, if I add equation number 1 and equation number 2, so this is for port number 1, we are having this for port number 1, we are having this equation for port number 2. Equation 1 and equation 2. Let's add this equation number 1 and equation number 2, then we will use this principle. This 4 equations we will substitute. So can I say, if we add this, can I say we will add this left hand side 2 cross 1, 2 cross 1, we will add this. So the next equation will be what? I1 prime plus I1 double prime, I2 prime plus I2 double prime. When we connect the left side of the equation, and what you can observe, you can observe here that Y1 prime and I1 prime and I1 double prime, this value is equivalent to what? I1 prime and I1 double prime, this is equivalent current, and that current is what? I1. So you can say here we can say this current is what? I1, and I2 prime and I2 double prime, when you go back and you see your original equation, I2 prime plus I2 double prime, this current is what? This current is known as I2. So I am writing this current as I2 current. One more thing. What is one more thing? Can I say V1 prime and V1 double prime is always equal? You can see here V1 prime and V1 double prime is equal, and this value is equivalent to V2, and V2 prime and V2 double prime is also equal, because this is the nature of parallel combination. So V1 double prime, so when you add this, can I say the left hand side will be what? The left hand side will be just I1 plus I2. So can I say, here I can write I1, I2. And what is next? Next you can say V1 prime, V2 prime, V1 double prime, V2 double prime, both quantities are same. If these quantities are same, I can take that value as common. If you take that value as common, what is remaining? Addition of this two matrices, 2 by 2 matrices. So you can say this value will be Y11 prime, Y11 double prime, Y12 prime plus Y12 double prime. Then we are having Y21 prime plus Y21 double prime, Y22 prime plus Y22 double prime. This multiplied by what? This multiplied by V1 and V2. So you can say this multiplied by V1 and V2. You can say this is what? I is equivalent to Y equivalent into V. So when a two-port network is given in which fashion? In parallel fashion, you can directly add the Y parameters. You can directly add which parameters? You can directly add the Y parameter. This is the story of this connection of two-port parameters. So you can say this is parallel connection. of two port, and this is the parallel connection of the two ports. So we have talked about everything. We have talked about the reciprocity condition. We have talked about the symmetrical condition. We have talked about what is the parallel combination of to when the Y parameter is given for a two port network. Now let's go to what? Let's go to the question based on this Y parameter. So we will talk about few previous year questions, and we will talk about some questions from the books. Okay, let's say this is one network and I am interested in the Y parameter of this network. So you can say this is given in the in which fashion this arrangement is given. So you can say the supply point or the top node of both the networks are connected and bottom node of the network is also connected. So if top node is connected to the same point, bottom node is connected to the same point, and you can say the output, in output we are also getting the same thing. Here we are having this. And here we are having reference point of the both two port networks are also connected. So top point is connected, bottom point is connected. You can say which combination it is. This combination is known as parallel combination. So what is the easiest task? You can convert this two port network into a single means you can find the equivalent, means I can convert this whole arrangement. I can convert this whole arrangement into this. This is, let's say, equivalent Y parameter, and this values are V1, this value is I1, this value is I2, and this value is V2. Correct? And we can find the value of y, and y can be converted into any other parameter. So let's talk about this. When I draw this two networks separately, can I say the network number 1, is what? This is 3 ohm, 3 ohm, 3 ohm. This is network number 1. 3 ohm, 3 ohm, and 3 ohm. Correct? What is network number 2? Network number 2, so when you flip this part, only this part is remaining. So another delta is available, and network number 2 looks like this. Here we are having network number 2, in which we are having, this is 2 ohm, this is 2 ohm, and this is also 2 ohm. This is 2 ohm, this is 2 ohm, and this is 2 ohm. This is our network number 2. This is our network number 1. As we know that if delta connection is given, we can find very easily. If delta connection is given, we can very easily find the y parameter. And what those y parameters are? For the first network, let's say for the first network, the y parameter for network number 1, as we have discussed yesterday, this y parameter is given by what? If this is, I am saying y parameter for network number 1, so what I have told you? I have told you that y parameter is given by 1 by 3 plus 1 by 3. How you define the y parameter? Yes, 1 by 3 plus 1 by 3. And what is the y11? 1 by 3 plus 1 by 3. y12, we have discussed this part yesterday. This is minus of 1 by 3. And y21, as we know that if your network is a complete resistive network, there is no need to calculate that reciprocal parameter. If this is minus 1 by 3, this is also minus of 1 by 3. And this value is what? 1 by 3 plus 1 by 3. So given network is both reciprocal and symmetrical. So y parameter for the first network, we can write 2 by 3 minus 1 by 3 minus 1 by 3 and 2 by 3. You can directly write it. Yesterday we have talked about it. Now we are interested in the y parameter for the second network. We are interested in for the y parameter of network number 2. And when we'll go to the network number 2, what you can say? What is y parameter? y11. So y11 is what? 1 by 2 plus 1 by 2. y12 is this, negative of this, minus 1 by 2. y21, again this network is also resistive plus resistive network, and resistive networks are always symmetrical, so this value is also minus 1 by 2. And what is this value? This value is 1 by 2 plus 1 by 2. So when I solve this, the equivalent will be, this value is 1, this value is minus 1 by 2, this value is also minus 1 by 2, and this value is 1. And this is the parallel combination of, this is the parallel combination of two port. So you can add the y parameter. So you can say the y equivalent is given by addition of the y parameter. And what is addition of the y parameter? 2 by 3 minus 1 by 3 minus 1 by 3 2 by 3 and plus what we are having? 1 minus 1 by 2. This value is 1. This value is minus 1 by 2. This value is minus 1 by 2. And this value is 1. When I add these two networks, this value will be what? 2 by 3 plus 1 is 5 by 3 minus 1 by 2 minus 5 by 6 minus 1 by minus 5 by 6. When you add this 1 by 2 and 1 by 3, this is minus 5 by 6. And last point is what? 2 by 3 plus 1 is 5 by 3. And this is the equivalent y parameter network. This network is known as what? Equivalent y parameter network. So when a network is given in the cascade, when a network is given in the cascade, you can calculate like this. So this is our first example. Let's try one question from gate. Let's take one PYQ based on the same concept. So let's go to the one PYQ. Let's take one PYQ based on the same concept. Yes, this is the PYQ. Okay. When you go through the question, what is given? The admittance parameter for a passive two-port network is shown in the figure. Okay. So two-port network, Y parameters are given, and what are the Y parameters? Y parameter is 5. Y12 is minus of 2.5. This value is minus of 2.5, and this value is 1. Network is, and this parameter is given as Y parameter. So you can say this parameter is Y parameter. What else is given? Let's say admittance parameter of a passive resistive network. A resistive network is given. This means it is necessary to be reciprocal network. Y11 is given, Y22 is given. So we have wrote the Y parameter. For this, Y parameter is given. Now the power delivered to RL in watts, they are talking about this. And RL in watts. Okay, so they are talking about the power delivered. For calculating the power delivered, what is needed? If you are talking about the delivered power, it is good to draw the Thevenin's equivalent across the load. It's good to draw the Thevenin's equivalent across the load. If I can convert this part, if I can replace this part by Thevenin's equivalent, it is easy for me to calculate the load for any power across any load. Here the load is given, means they are not talking about the maximum power transfer, they are just talking about what is the power delivered to the load. But when you look at this, can I say the top node of, I can consider this 3 as my one of the parallel network. Means one network is this resistive two-port network, and in parallel to that network 1 3 ohm resistance is given. Means these two networks are given in parallel, because the one node is same for both and 2 dash node is also same for both. If this is so, can I say this network number 1, and I can consider this as network number 2. So what is first job? First job is to find the equivalent Y parameter. Once we know the equivalent Y parameter, we can calculate the whatever they are asking, maximum power or anything we can calculate. So can I say I can convert this whole portion, this 2 network, into a single network. So can I say I can convert this whole network like this. This box represents equivalent Y parameter. And here we are having two-port. So here we are having 2-port. What else is given? Else is given as this. A 20 volt is connected at input. Volt is connected like this, and what else is given? 6 load resistance is also given. Can I say if I am replacing my load, if I remove this load, this voltage available here is V2, and this V2 voltage can be represented by VTH. Just think about the Thevenin's equivalent. What Thevenin's equivalent says, remove your load and whatever voltage you calculate at output is known as Thevenin's voltage, or this voltage is also known as open circuit voltage. So if we are interested in the Thevenin's equivalent, in Thevenin's equivalent we are interested in Thevenin's voltage and Thevenin's current. So we'll talk about that part on. Okay, but what is the first thing? First thing, I am interested in the Y equivalent. So as we know, for the network number 1, as we know for network number 1, two-port parameter is given, and I am considering this as a network number 2. So for network number 2, what is two-port parameter? Okay, Y parameter for this. Y parameter for what? Y parameter for network number 2. And what is your network number 2? When you look at the network number 2, the network 2 now means this 2 and 2 prime. When I look at this, you can say 2 and 2 prime is the voltage which is valid for this network and this 3 ohm resistance. And 1 and 1 prime is the voltage which is common for both network number 1 and network number 2. So network number 2 is nothing but 3 ohm resistance. This is known as, which point it is given? 1 prime, 2 prime. Correct? For this we have to write what? For this we have to write what? For this we have to write the Y parameter. How I can write the Y parameter? It is very simple. From our theory of let's say, again I am considering one delta, so you can say this value is having delta and this value is infinite, and this is also one delta component of the delta network, and resistance of that component is also infinite because nothing is connected here, so I am taking it infinite. But if delta network is given, I can write the Y parameter directly. What is Y parameter? 1 by R1, 1 by infinite is 0 plus this 1 by 3. What is this parameter? Y12 parameter is negative of minus 1 by 3. Y21 parameter is what? Y21 parameter is, again, this is resistive network, so reciprocal. And from here 1 by R2 is infinite, 1 by infinite is 0 plus this is 1 by 3. This is the Y parameter for the second network. You don't need to calculate anything. Network number 2. If both Y parameters are given, and as you know that this equivalent Y parameter is summation of this two parameters. So can I say the equivalent Y parameter is given by, if I am interested in the equivalent Y parameter, this is summation of what? This is summation of the first quantity which is given by 5 minus 5 by 2 minus 5 by 2 and 1. And what is second number? The second number we are having here is this 1 by 3 minus 1 by 3 minus 1 by 3 and 1 by 3. I can get the equivalent of this. What is equivalent of this? The equivalent of this is given by equivalent of this is given by equivalent Y parameter. 5 plus 1 by 3, 15, 15 plus 1, 16, 16 by 3. This is 16 divided by 3. Minus 5 by 2 minus 1 by 3. Minus 5 by 2 minus 1 by 3. LCM is 6. This 3. Minus 15. And this is 2. So minus 2. Minus 17 by 6. Minus 15 minus 2. Minus 17 by 6. Then what is next? Next we are having is minus 5 by 2 and minus 1 by 3, still same, minus 17 by 6. And what else we are having? 1 plus 1 by 3 is 4 by 3. 4 by 3. So you have converted whole your network into this Y parameter. Now can I say this Y parameter is nothing but I1, I2. I1 is equivalent to what? 16 by 3 V1 minus 17 by 6 V2. Because when I am writing the Y parameter, what is the format? The format is I is equivalent to Y into V. I is equivalent to Y into V. So this is the story. And what is I2? I2 can be written as minus of 17 by 6 V1 plus 4 by 3 V2. Correct? These two equations are given for input port and output port. These two equations are given for what? These two equations are given for input port and output port. Now, what we want to say? Here, few things are given. What things are given? If I am interested in the Thevenin's voltage, I have to make I2 equal to 0 and value of V2 will be what? If I make I2 equal to 0 means how you can calculate the Thevenin's equivalent? The idea of Thevenin's equivalent is very simple. Just remove the load resistance and calculate the V2. So can I say to calculate the Thevenin's equivalent, what is the story? If I make I2 equal to 0, I2 equal to 0 means load is removed. Then V2 will be what? In this condition, V2 will be VTH, or V2 is also known as V open circuit voltage. What is the value of V1? So the value of V1 is what? V1 is 20 volt. So it is also given that the value of V1 is 20 volt. Because V1 is the voltage will appears here and we are drawing equivalent across these 2 points, so V1 is 20 volt. So that put this to value. If I put I2 equal to 0, this value is 0. So you can say 17 by 6 V1 equal to 4 by 3 V2. So 17 by 6, what is V1? V1 is given as 20 volt equal to 4 by 3 V2, and this V2 is also known as VTH. So when you cancel it, 3 2s are 4 5s are, and this value will be what? 17. This value will be what? 17 into 5 divided by 2. 42.5 volt is the value of V2, or you can say this value is the open circuited voltage. Fine. Now we are interested in what? We are interested in the next parameter. We are interested in what? The next parameter we are interested in the because we are calculating the Thevenin's equivalent, and for calculating the Thevenin's equivalent, if VTH is given, now we are interested in RTH. So what is theory behind calculation of RTH? How you can calculate the RTH? The theory of RTH is very simple. How to calculate RTH? RTH can be calculated let's recall that theory. You can calculate the RTH by making all independent sources equal to 0. Means you can replace the voltage source by its internal resistance, or you can say by short circuit. You can replace the current source by open circuit. So deactivate all the sources from the circuit and apply a test source from outside. And apply a test source. Suppose this is your network, and if you are interested in calculating the Thevenin's resistance, the idea is very simple. You can call this value as VT, and you can say this current value is IT. Provided all independent sources are 0 for this network. So if you are aware of this fact, can I say this VT divided by IT ratio is known as RTH. From our network point of view, what I can say, if I make independent source equal to 0, what is independent source you are having in the network? The independent source you are having in the network is 20 volt, and 20 volt is what? V1. So can I say our independent source is what? We are making V1 equal to 0. If you make V1 equal to 0, then what is V2, VT and IT? The ratio of VT is V2 and IT is I2. Then V2 by I2 ratio is known as RTH of the network. This ratio is known as RTH of the network. So let's make V1 equal to 0. If you make V1 equal to 0, these are two equations. If I make this equal to 0, this equal to 0. So first we are having I1 equal to, if you are making V1 equal to 0, I1 equal to minus 17 by 6 V2. Minus 17 by 6 V2. What else we are having? And we are making V1 equal to 0. So I2 and V2 ratio is what? I2 equal to I2 equal to what? If you are making V1 equal to 0, I2 equal to 4 by 3 V2. You can call this 4 by 3 V2. We are not interested in this equation because our solution is directly given. The V2 divided by I2 ratio. V2 divided by I2 ratio is what? Let's say I am considering this V1 and V2 as a source. So if we are considering V1 and V2 as a source voltage and test current, then V2 by I2 ratio is what? V2 by I2 ratio is known as Thevenin's resistance. So what is Thevenin's resistance? Thevenin's resistance for this circuit is given as 3 by 4. 3 by 4 is 0.75. Correct? Now we know the complete Thevenin's equivalent of this. Can I say, if I draw the Thevenin's equivalent for the network will looks like this. First is VTH. And this is RTH. VTH, RTH. And a load. Load is already given. What is the value of load? You can say the value of load for the network is 6 ohm. So you can say this value is given as 6 ohm. What is the value of RTH? The value of RTH is given as 0.75. And what is the value of VTH? VTH is given by what? 42.5 volt. Means 4 5s are 3 2s are 42.5. Where it is? This value is known as 42.5 volt. Now we want to know the power dissipation across what? What is question? The question is, what is the power dissipation? What is power delivered to RL? No, they are not talking about the maximum power transfer. They are just asking about if they are connecting a 6 volt load, then what is power delivered to the 6 volt load? So, okay, what is current in the circuit? So you can say the current in the circuit is given by, if this current is I, so applied potential, which is 42.5 volt divided by 6 plus 0.75. Current of the circuit is known, and this current is what? This current is given by 42.5 divided by 6.75. This value is 6.296. Now what is the voltage across this 6 ohm resistance? If I am calculating the power delivered due to DC, it's a V into I. So 6.629 multiplied by 6, 37.778 is the voltage drop across 6 ohm resistance. We are interested in the power. So how you define the power? The power is given by V into I product. So V into I product is 6.296 multiplied by 37.778, this much of watt. And when you multiply this 6.296 multiplied by 37.778, this value will be 237.85 watt. So as we have discussed in Z parameter also, whenever you are having question from this maximum power transfer theorem or power across any load, you can always use this concept. This concept is what? Convert the right side network into the Thevenin's equivalent, and Thevenin's equivalent will give you everything which is required to calculate the power delivered to the load. Or they can ask one more question, what is the maximum power means if this RL, if they remove this 6 ohm, and if they ask what is the maximum power transfer, so you can calculate the condition for maximum power transfer. You can calculate the power transfer also, because we know which theorem is applied in that case. In that case, with the theorem which we will use is maximum power transfer theorem. In case if RL is not given, if RL is not given, you have to use the maximum power transfer theorem. I hope this is clear. So these two questions are based on the Y parameter, in which concept is used, in which the concept of the parallel combination is used. Let's take few more questions into the discussion so that, okay, these all are PYQs from 21 to 25. I have taken all the PYQs, and in this question also they are talking about, in this question also they are talking about the Y parameter, Y21 parameter. Okay, what is Y21 parameter? Y21 parameter is given by what? I2 divided by V1 ratio. It is I2 divided by V1 ratio, by making what? By making V2 equal to 0. This is Y21 parameter. So in this question, if I make V2 equal to 0, V2 equal to 0 means what? This portion is short circuited. This portion is short circuited. V2 equal to 0 means what? This portion, this part of the network is short circuited. Let's say we are considering this point is our reference point, and I am taking my reference point as 0 volt. What I am taking this reference point as 0 volt, because I will directly get Y21. I will not calculate whole parameter. So from short circuit I can copy this 0 from here to here. If you can copy this 0 from here to here, what is current in this branch? The current in this branch is what? the current in this branch is V1 divided by 2. Higher potential minus lower potential divided by resistance is current. So this is V1 divided by 2. Correct? Now what I can say, what is current in this branch? If what is current in this branch? So can I say, if this potential is 0 volt and this potential is what? If this is 0, this potential is minus 8 V1. Can you have the current due to the potential difference of 0 and minus V81? So you can say minus 8 V1. This current will be 0 minus of minus 8 V1 divided by how much? 4. So this current is what? This current is 2 V1. This current is 2 V1. Now you can easily calculate. Just apply a KCL here. What is the incoming current to the node? So you can say, just a KCL can answer our question. KCL at 0 volt node. KCL at 0 volt. What is incoming current? Incoming current is V1 by 2. So I will write V1 by 2 here. What is one more incoming current? I2. So I will write I2 here. This is equivalent to, because I am only interested in the ratio of I2 by V1. So I will not include any other parameter in my discussion. I will not involve any other parameter in my discussion. So 2 incoming current is I2, 1 current is V1 by 2, and one more current which is going away from the node is 2V1. So I am writing this parameter as 2V1. Now I2 is equivalent to 2V1 minus V1 by 2. So 2 minus half is 3 by 2 V1. And can I answer it? I can answer it in one line. I am interested in I2 by V1 ratio. So I2 divided by V1 ratio by making V2 equal to 0. I2 by V1 ratio, that is equivalent to 3 by 2. So what is correct answer for this? The correct answer for this question is 1.5. They are asking about Y21 parameter, and Y21 parameter for this question is what? Y21 parameter for this question is 1.5. I hope you have understood it. So this is the, and you can calculate the Y11 parameter also. I1 equal to V1 by 2. So I1 divided by V1 ratio is 1 by 2, but they are not asking it, so we will not, because the very simple circuit. Why we will calculate all the parameters? Okay. Again, one question is based on what? Again, one question is based on maximum power transfer. So this is the very important category of the question when two port is mixed with what? Two port is mixed with the maximum power transfer theorem. Two port plus maximum power transfer is very important category of question. Very important category of the question comes from two port and maximum power transfer. So how we can calculate this? Let's go. Again, whenever we are talking about the maximum power transfer theorem, the very easy idea is, a very simple idea is what? Simple idea is convert this into the Thevenin's equivalent. Thevenin's or Norton, you can convert it into any, both are fine. Convert this part into Thevenin's equivalent. Calculate this, convert this part into Thevenin's equivalent. Thevenin's equivalent. And this is again a 2-mark question and very simple question. What is the condition for maximum power transfer theorem? So you can say, when we are talking about the DC, if the Thevenin's equivalent, Thevenin's resistance and its load resistance are equal, then, and we are selecting for load, which load can take maximum power. The load which is having value equivalent to Thevenin's resistance can take maximum power. So let's talk about this. Two-port and maximum power transfer theorem. So what is given? The given data is this. Given data is this. What we can write? I1, we can write I1, I2, I1 equal to what? I1 equal to 2 by 100 times of V1 means here we are having what? The Y parameter is what? The format for the equation is what? I is equivalent to Y into V. I is equivalent to what? Y into V. So I is what? Here we can write V1, V2. If I write V1, V2 here, it is 2 by 100, and always remember when you are multiplying 1 by 100 to the matrix, it is multiplied to the every component, every parameter. So 2 by 100 times of V1. Then what I can write? Minus of 1 by 100 times of V2. Then it is multiplied by minus 1 by 100 times of V1, and this value can be written as 4 by 300 times of V2. This is the information which is given. What else is given? The one more given information is what? The one more information you can say, here we are having current I1. Here we are having current what? This current is I1. If this current is I1, what is the format we are having for here? It is 120 volt. And this value is what? This current is I1. Because a two-port network is given for the fixed value. This potential is V1, this current going inside the network is I1, and this value is V2. So this value is 10 ohm. So if this is 10 ohm and this current is I1, so this is what? Plus minus of 10 into I1. Then what is value of V1? You can say 120 minus 10 I1 is the value of V1. V1 is what? V1 is the potential which is defined here. This potential is V1. This potential is V2 as per our two-port network theory. So V1 and V2 are given here. So what is V1? I can write the value of V1 is 120 minus of 10 I1. This whole information is given. A two-port network is given. For that Y parameter is given. The value of load impedance ZL. So they have connected one load so that maximum power transfer can be transferred from source to load. So they are asking maximum power transfer. The value of ZL in which maximum power transfer will be. Okay. They are talking about ZL only. What is the value of ZL so that you can transfer the maximum power from source to load. So in this question, they are not asking the maximum power transfer. They are just asking about the Thevenin's equivalent resistance. But we will calculate both. We will calculate both so that we can repeat the concept. So what I have told you, convert this right part of the circuit into Thevenin's equivalent. So when I convert this into Thevenin's equivalent, my Thevenin's equivalent will looks like this. I can say this value is VTH. This value is RTH. And if you are talking about the maximum power transfer theorem, so can I say at MPT, at maximum power transfer, how your circuit will looks like? Your circuit will looks like this. This is also RTH. This is the condition when you can say the maximum power is transferred from source to load. The idea of calculating the VTH is same. What is VTH? So again, we will use our basic principle. Just remove the load from the circuit. If you remove this load from the circuit, the I2 will be 0. Then the value of V2 will be what? Then the value of V2 will be what? VTH or V open circuit. So let me write it. I am repeating our previous step. What is the first step? You can say remove RL. Remove the load resistance, first step. And removing of the load resistance will gives you what? The removing of the load resistance will make I2 equal to 0. And if I2 equal to 0, you can calculate, say V2 will be open circuited voltage, or you can say the V2 will be what? Thevenin's voltage. This is the whole story, and this story is applicable to the all two-port networks whenever you want. This is applicable to the all two-port networks whenever you want the Thevenin's equivalent or maximum power transfer or anything. Correct? So let's do this. What they are saying? They are saying that make I2 equal to 0. If I make I2 equal to 0, then V2 will be VTH. So if I make I2 equal to 0, can I say minus of I2 equal to 0 minus of 1 by 100 times of V1 minus of 1 by 100 times of V1 plus 4 by 300 times of V2, and V2 will be what? V2 is now open circuited voltage, and this value is equivalent to 0. If this value is equivalent to 0, you can say V1 divided by 100 is equivalent to 4 divided by 300 times of V open circuit voltage. 20 cancel. So V open circuit voltage is given by 3 by 4 times of V1, and this is known as VTH. This is the one equation. Another equation, if I make I2 equal to 0, okay, one equation we are having from here. I can write V1 is equivalent to what? 120 minus 10 I1. So V1 is equivalent to 120 minus 10 I1. And what else we are having? The first equation we are having, I1 is equivalent to 2 by 100 times of V1. I can write this value as 120 minus 10 I1. Although they are not asking this. They are just asking what? They are just asking the RTH, which is very simple to calculate, because RTH, what is the idea of calculating the RTH? The idea of calculating the RTH is very simple. Remove the load and connect a test source and make all independent sources equal to 0. Easy calculation, but we can calculate both. So I1 equal to this and plus 4 by 300 times of V2 plus 4 by 300 times 2 by 100 times of V1, 2 by 100 times of V1, and minus 1 by 100 times of V2, minus of 1 by 100 times of VTH. Correct? And one of the relationship we are having here. So we can have the directly relationship between V1, VOC. Okay, I can write I1 is equivalent to 240 divided by 100 minus 20 by 100 into I1, and this value will be what? Minus of 1 by 100, and instead of writing VTH, I can write the value of what? VTH is given in form of V1. So this is 3 by 4 of V1. Now you are having the direct relationship between V1 and I1. V1 and I1. So what is that relationship? You can say I1 plus I1 by 5. I1 plus I1 by 5. I1 plus I1 by 5 equal to, this is 1.2. Okay. This is 2.4 times of 2.4 minus 3 by 400. Or you can say 6 I1 by 5. 6 I1 by 5 is equivalent to what? 2.4 minus 3 by 400 into V1. Yes. Or you can say 6 I1 12 minus 3 by 80 V1. These equations are given. VOC equal to 3 by 4 of V1. Any other equation can help us to solve? Okay, this is equation number 1. What is value? The value of I2 is equivalent to 0. I2 equal to 0. So one direct relationship between we are having in this. This value is I1 equal to 2 minus 1 by 160 V1. And V1 and I1 relationship, okay, one of the part is this, and with the help of this equation we can calculate V2. Another part which they are asking in the exam is this: what is the value of ZL so that you can transfer the maximum power? So you know that how to calculate ZL by making this part equal to 0. Means what is idea for calculating the ZTH? The idea for calculating the ZTH is this: if this is two-port network, deactivate all voltage source and current source. Independent current source equal to 0, and connect one external voltage source. Call this voltage source as VT, and current drawn by this voltage source is IT. Then you can say this VT by IT ratio is what? RTH. Okay. So what we are doing? If I am making all independent sources equal to 0, if I am making all independent sources equal to 0 means 120 volt by replaced by 0. If 120 volt is replaced by 0, this is 0. So what is value of V1? the V1 is equivalent to minus of 10 I1. This is one of the equation. And we want V2 by I2 ratio. So can I say V2 by I2 ratio? So we want the value of V1. V1 equal to minus 10 of I1. So V1 equal to minus 10 of I1. So I1 2 by 100 minus 10 I1 minus V2 divided by 100, and this value will be what? I1 plus 20 by 100 I1 equal to minus of V2 divided by 100. So you can say minus of V2 is equivalent to 100 cancel, 120 I1. V2 equal to minus of 120 I1. So let's use this, V2 equal to minus of 120 I1. Now we can find the V2 by I2 ratio by putting this in equation number 2. I2. What is I2? I2 I will write as it is, because VT is V2 and IT is I2. So I will write here I2 is equivalent to what? Minus 10 times of V1. So minus of 1 by 100 times of V1. Minus of 1 by 100 times of V1. When you can calculate this, V2 divided by V1 is equivalent to minus 120 I1 divided by minus 10 I1. It is cancelled. So V2 equal to what? V2 equal to 12 times of V1. So this value is what? This value is 2 by 100 times of minus 1 by 100 times of V1, and we don't want V1, we want V2. So V1 can be written as V2 divided by 12. Fine. And what else is needed? The else is needed 3 by 400 V2. 3 by 400 V2. We are interested in the V2 by I2 ratio. So you can say I2 is equivalent to, if I take V2 as common, 3 by 400 minus 1 by 1200. So you have to multiply both the thing by 3. So this value is I2 equal to V2. 9 minus 1 is 8 divided by 1200. So V2 by I2 ratio is what? 1200 divided by 8. So you can say 1200 divided by 8. 8 2s are 4 2s are 4 3s are. So what is correct answer? Correct answer is 150 ohm. So if you want to transfer the maximum power from source to load, the value will be what? The value will be what? 150 ohm. I hope this is clear. Again, one more question. Let's take few more questions on this. Okay, this is the next question, and in this question what they are asking the Y parameter. This is again PYQ. This is again a previous year question. You can check in your booklet. They are asking the Y parameter for this network. So how to calculate the Y parameter? To calculate the Y parameter, let's take V2 equal to 0. What is the first thing we can do? We can make V2 equal to 0. By making V2 equal to 0, what we can have? We can have this. this value is 1. This value is 3v2. This value is 1. And this value is also 1. What we are saying, we are making V2 equal to 0, and this current is what? This current is I2. And this value is V1, and this current is I1. This is the whole story. Now, how we can calculate? By making V2 equal to 0, whenever I am connecting my output to the 0, this means I am short circuiting my output port. If output port is short circuited, can I say V2 is equivalent to 0? So how many parameters I can calculate? I can calculate the ratio of V1 by I1, and I can calculate the ratio of V1, I1, V1 and I2. I2 by V1 ratio I can calculate. So let's go to this. If I consider this point as my reference 0 volt, this whole point is also 0 volt. If this is 0 volt, what is current going inside this? 0. So I2 current is coming from the source, but current going inside this is 0. So this current is also what? This current is I2. Okay, we are good about this. Now, can I say this current is what? This current is V1 divided by 1. V1. This current is what? V1 divided by 1. So what is current coming from here? Current coming from here is V1, or let's take a simple thing. What is current? What is this potential? This potential is also V1, because this is one short circuited line. So this current is V1 divided by 1. And what is this current? This current is also V1 divided by 1. This current is also V1 divided by 1. Why this current is V1 divided by 1? Because higher potential is V1, lower potential is 0. Higher potential minus lower potential divided by resistance is equivalent to current. So can I say the value of I1, if I apply a KCL at this node, can I say the value of I1 is incoming current, and can I say the value of KCL at which node? Only this analysis can give you, only this analysis will give you answer. Nothing else is required. So can I say incoming current is I1? So I will write I1 here. What is outgoing current? So outgoing current is V1. So I am writing V1 here. This current is incoming. This current is incoming. This value is 3V2. Okay, V2 is equivalent to 0. So I can consider this as my open circuited. Okay, if this is open circuited, things are very easy. I can write direct solution also, but anyways, means I have considered this as V1, that's why we are calculating that much. But yes, fine. V1 is equal, V1 by 1 is going away from the node, and I1 current is coming to the node. And what is one more current which is going away from the node? Is V1. So first parameter is given, I1 divided by V1 ratio. By making V2 equal to 0, this parameter is Y11, and Y11 can be written as 2. So in all the options, who is having Y11 equal to 2, this can be true, this cannot be true, this can be true, and this can be true. Okay, 3 options. You can eliminate only one option. What is next thing we can have? You can say that here we are having I2, and the same branch current is given by V1 by 1. So you can say I2 is equivalent to minus V1. So because this represents the same current. One current is going in this direction, another current is going in the opposite direction, and both currents are same. So can I say the I2 divided by V1 ratio by making V2 equal to 0 is which parameter? y21, and y21 is equivalent to -1. So y21 is equivalent to -1 is available here. So this option cannot be true, this cannot be true, and this cannot be true. Which option is true? The C option is true, but we are not matching option. We will solve the whole story. What is the next part? Okay, this is the first part. What is the next part? Next part is by making V1 equal to 0. So if I make V1 equal to 0, let me redraw the circuit. Here I can redraw the circuit. This value is V1. This value is I1. V2. This value is 1. And this value is also 1. This value is V2. This value is I2. In this network, you can calculate the Y parameter directly also. 1 by 1 plus 1 by 1 is 1 parameter. So that is what 1 by 1 plus 1 by 1 is 2. And because this is when you make V2 equal to 0, this whole combination is a, which combination? This whole combination is a delta combination. And for delta combination, you know, you can write the Y parameter directly. But anyways, okay, these are whole numbers. This value is what? 1 ohm. Now, what you are doing? You are making V1 equal to 0. So, you are replacing V1 by short circuited. If you are replacing V1 by short circuited, and if I am taking this potential as 0, V reference equal to 0, what is potential here? Short circuit will copy for this potential from here to here. So this potential is also 0 volt. If this potential is 0 volt, 0 volt minus 0 volt divided by 1. What is current going in this branch? This current is also 0 ampere. So can I say if this is V2 and this is ground, what is current you can expect here? V2 divided by 1 current you can expect here. And what is the current in this branch? The current in this branch is equivalent to V2 minus 0 divided by 1. So this current is what? This current is V2 divided by 1. Now by applying a simple KCL at this node, KCL at V2 node, we can calculate one of the parameter. And what is that parameter? Incoming current is I2 and outgoing currents are what? Outgoing currents is V2 plus V2 is 2V2. So I2 divided by V2 ratio is what? This ratio is 2, and that parameter is known as Y22 parameter. So here you can check the Y22 parameter is what? Y22 parameter is again 2. What else we are interested in? Else we are interested in this. Let's say this current is I1. What is current here? This current is I1. And let's apply KCL at 0 volt node. I am applying KCL at which point? I am applying KCL at this point. So incoming current is I1. Incoming current is 3V2. and one more incoming current is what? V2. Sum of all current equal to 0, because that's what KCL says, that summation of the current at a node is always equivalent to 0. If summation of the current at a node is always equivalent to 0, I can say what is the value of I1? I1 is equivalent to minus of 4 times of V2. So I am interested in the I1 by V2 ratio, and that ratio is equivalent to minus 4. That ratio is known as Y12. So what is value of Y12? Y12 is minus 4. So all parameter you can calculate for this network. Okay, let's take one more question, and we are interested in calculating the Y parameter for this. Y parameter for this network. How we can calculate the Y parameter? Again, Y parameter can be calculated. Y parameter can be calculated by making V1 and V2 equal to 0. So let's do this. First we are doing what? First we are making V2 equal to 0, or let's make V1 equal to 0. If I make V1 equal to 0, what is our network? If I am making V1 equal to 0, V1 is also equivalent to 0. And this value will be plus minus. Okay. Let me check the original question, because it is plus here. So let me check it. Two, one. This is the Valkenburg question, so let me write it. What is the polarity given here? The polarity is plus minus 3V1. Okay. So if I am making V1 equal to 0, so V1 equal to 0 means 3V1 is also equivalent to 0, and here we are having 1 ohm resistance. This value is V2, this value is I2, and we are making V2 equal to V1 equal to 0. So this whole value is V reference. V reference equal to 0 means this potential is also equivalent to 0. And what is current entering from here? This current is I1. But this current is not going into 2 ohm resistance. So this current is what? 0. The current across a resistance is given by higher potential minus lower potential divided by resistance is 0. Can I say if this potential is V2, V2 is divided into 2 parts. The one part is V2 to ground, another part is V2 to ground. So can I say V2, what is current here? Current here is V2 divided by 1. And what is current here? This current is V2 divided by 1. The moment you write it, you can calculate the value. And what is, if I divide I2, can I say the same branch current is given by I2 divided by 2? And same current here is given by I2 divided by 2. Both the current should be same, because I2 will divide into 2 parallel paths. V2 to ground, V2 to ground. So, and both resistances are same. So you can say I2 current is divided into 2 parts. So you are having 2 current in one branch. So you can say I2 by 2 must be equal to V2. So you can say I2 divided by V2 ratio is what? 2. And that value is known as Y22. One more thing. If this current is I1, I1 is not going into this 2 ohm resistance. So can I say this current is I1? And now you can equate this two. I1 is equivalent to what? Minus of 2 times, I1 is equivalent to what? I1 is equivalent to minus of V2. So you can say I1 divided by V2. This part is known as Y12 and Y12 ratio is -1. This is one of the parameter. This is another parameter. You can calculate it. It is in very simple way. Now, what if you make V2 equal to 0? If you make V2 equal to 0, and let's analyze. Let's calculate remaining two parameter. In exam, they will ask you to calculate one parameter or two. They will not tell you to calculate all the parameters. If they tell you to calculate all parameters, you can calculate it. That is more simple. So if you are making V2 equal to 0, what is next? If you are making V2 equal to 0, how your network will looks like? Your network will looks like this. If you are making V2 equal to 0, this is V1. This is V1. This is 2. This is 1. This value is what? Plus minus 3V1. Correct? And what else we are having? This is 1. And we are saying what? We are saying that this value is equivalent to 0. V2 is equivalent to 0 and I am taking this current as I2. Fine. Now we can calculate the condition. Which condition we are using? We are using the condition when output port is short circuited. V2 is equivalent to 0. Now, if I consider this voltage as V reference, if I consider this voltage as my V reference voltage, if I make this voltage as V2 equal to 0, V reference is also equivalent to 0, so I can copy this voltage here. This voltage is also 0. If this voltage is 0, can I say, if this potential is V1, what is current here? The current here is V1 divided by 2. If this current is V1 divided by 2, here the 0 volt is given, then what I can say, this positive terminal will deliver 3V1. So this is 3V1, this is V1. What is current you can expect here? The current you can expect here in this direction is 3V1 minus V1 is 2V1. Now you can apply a very simple KCL to get answer. So this is I1. So what is value of I1? So you can say I1 is equivalent to, I1 is current incoming to the node. 2V1 is also current which is incoming to the node, and outgoing current is V1 divided by 2. So you can say I1 is equivalent to what? Minus of 1.5 V1. So you can say the ratio of I1 divided by V1 by making V2 equal to 0, that will gives you Y11, and that ratio is what? Minus of 1.5 volt. Correct? Now what else we can say? We can say that what is the current in this branch? Because current across a resistance is given by potential difference divided by resistance equal to current. So whole I2 current will enter here. If I2 current will enter here, can I say, if I2 current will enter here, can I say I2 and 2V1 is same? Because both represents the current of the same branch. If both represents the current of the same branch, you can say 2V1 is equivalent to I2. And I am interested in the ratio of I2 divided by V1. Then I2 divided by V1 represents what? I2 divided by V1 represents the Y21, and this ratio is equivalent to 2. These are all 4 Y parameters. I hope this is clear. So these are questions in all varieties when we are having independent sources, when we are having when we are having a resistive network, or when we are having dependent sources. Okay, let's take one more question, and this is the question. What this question is saying: a linear two-port network shown in the figure, an ideal DC voltage source of 10 volt is connected across port 1. So they are saying that a 10 volt source is connected across port 1. This is port 1 and 10 volt source is connected. So you can say this V1 is 10 volt. It is directly given. What else is given? The next information is a variable resistor R is connected across port number 2. A variable resistor R is connected at port 2, and this resistor you can vary. So what we are saying, a variable resistor R is connected across. So I think this diagram is self-explanatory diagram. This R is also given. What else they are saying? The voltage measured across port 2 is shown in the figure. They are saying that if you measure the voltage across port 2, the measured voltage and current across port 2 is given V2 versus minus I2 plot. Okay, this voltage across this variable resistance and I2, this value is given. V2 equal to 5 volt, I2 equal to 0. Okay, V2 equal to 5 volt when I2 is equivalent to 0. So always remember, I2 is the current which is moving inside the network. So minus I2 represents the current in which direction? The minus I2 represents the current in this direction. Minus I2 represents the current which is going in this direction. That's why this is the graph between V2 and I2 is going in this direction. That's why they have written minus I2 here. Okay. For V2 equal to 0, I2 equal to, for V2 equal to 0, V2 equal to 5 volt, I2 equal to 0 milliampere. For V2 equal to 4 volt, I2 equal to minus 4. Okay, this is the output characteristic is given. Now what they are saying, okay, I2 in milliampere. Okay, port 2 is replaced by, the resistance R is replaced by this. Okay, what if they replace this output RL by this network? 1 kilo ohm and 10 volt combination. Then what will be the current in the network? Okay, fine. What I have told you, whenever they talk about any current voltage or the power transfer or load current, they just calculate this portion into, convert this portion into what? Thevenin's equivalent. Thevenin's equivalent. What is the idea to calculate the Thevenin's equivalent? Idea to calculate the Thevenin's equivalent is what? One of the idea is what? One of the idea is make independent source equal to 0 and calculate the V2 by I2 ratio. But here V2 by I2 ratio, V test by I test ratio, we can calculate that. But output characteristic is given, and if output characteristic is given, can I say the current is 0? Current is 0 means what? When I can make this current is equivalent to 0? Current is 0 when load equal to infinite. So can I say this is the condition when we are removing the load from the circuit? And if you are removing load from the circuit, can I say when RL equal to 0, when RL is equivalent to infinite, then only the current I2 will be what? 0. Then only current I2 will be 0. And if load is removed, the voltage obtained is known as open circuit voltage or Thevenin's voltage. So Thevenin's voltage is directly given for the network. And what is Thevenin's voltage? Thevenin's voltage is given as 5 volt. So you can say VTH is directly given for the network and that value is equivalent to 5 volt. What else is given? What else is given? This is one of the information I can identify, because as we know, the point where current is 0 is known as open circuited voltage. Now, next point. Can I write the equation for this line so that I can calculate? Because this equation, this line will intersect. This line will intersect the x-axis, and the line will intersect the x-axis. That point is known as what? This is the point of maximum. That is the point of maximum current, and maximum current is known as short circuit current. This point will be maximum current and 0 voltage. So which current is this? Short circuit current. So can I calculate the equation of this line and make V2 equal to 0 so that I can get the value of okay, what is equation of line? So you can say y-axis can be represented as this y-axis. The line is what? The equation for line is y equal to mx plus c. So you can write y-axis means here in our case it is V2 is equivalent to slope. What is the slope? The slope of this line is given by y2 minus y1. And what is y2 minus y1? Minus 1 volt divided by x2 minus x1. x2 minus x1 is minus 1 by 4 milliampere. So can I say the slope is given minus 1 by 4 milliampere? Keep one thing in mind, this 1 volt is given in normal value. This is minus 1 volt divided by 4 milliampere. So y equal to m into x. What is x-axis? X-axis is given by minus I2. Correct? Y equal to mx plus c. What c represents? C represents the intersection of this y-axis, and that value is given as 5. This is the equation of given graph. Now what I can say? I can say that if this equation is given, I can say that I2 will represent short circuit current if I make V2 equal to 0. Because if I make V2 equal to 0, you are bringing this line here, and that line with this point will be here or somewhere outside of this board. But when this line intersect with the x-axis, that is the point where the y magnitude is 0. When V2 is 0, this is what? The short circuit current. So can I say, if you make V2 equal to 0, what I can have? I2 equal to I2 divided by 4 milliampere equal to 5 minus 5. I2 equal to what? Minus of 20 milliampere. And that current is known as short circuit current. But you have to keep one more thing in mind. I2 is the current which is going inside the network. We are interested in the current which is coming out, which is flowing like this. So you can say ISC is equivalent to 20 milliampere. ISC and which current I am taking ISC? I am taking this current as ISC. So keep one thing in mind, minus I2 and ISC are same thing. Now open circuit voltage and short circuit current both are given. The ratio of open circuit voltage and short circuit current represents the RTH. So RTH for the network is given by what? Open circuit voltage. What is open circuit voltage we are having? What is open circuit voltage we are having? The open circuit voltage we are having is 5 volt. And what is short circuit current? 20 milliampere. So this value will be what? 5 divided by 20 kilo. 5000 divided by 20. This value is what? 250 ohm. Now we know the VTH, RTH, now we can calculate anything. Can I say? They are asking the value of I2. So we can say the value of I2 can be VTH. This is 5 volt. And Thevenin's resistance is 250 ohm. And what else? They are saying that they are using new load. New load is 10 volt and in series with 1 kilo ohm. So you are having let's make it 1000 ohm to make same unit, and this is 10 volt. Always remember what they are asking. They are not asking the short circuit current. They are asking the current which is going inside this. So they are asking about which current. They are asking about this current. So what is this current? Higher potential minus lower potential. 10 minus 5 divided by 1250, which is equivalent to 5. Potential difference divided by resistance is current, and this is higher potential, this is lower potential. Okay. This value is 10 volt. So this is higher potential, this is lower potential. So higher potential to lower potential divided by resistance is equivalent to current I2. And in this value current is 1250. This value is 250. 1 divided by 250. Let's multiply it and divide by 1000. So 1000 divided by 250 into 1000. 250, 1000 divided by 250 is 4. 1 divided by 1000 is milliampere. So what is correct answer for this? The correct answer for the question is 2 milliampere. 4 milliampere is the correct answer. So I hope you have understood the theory of Y parameter. In this session we have talked about every variety of the question which can be asked in the exam. We have talked about the symmetrical Y parameter condition. We have talked about the question based on resistive network. We have talked about the question about dependent sources. Then we have talked about the question based on the combination of Y parameter two-port network. And this is again very one simple question. What they are asking in this question, in the circuit shown figure, in the circuit shown below, the network N is described by Y matrix. Okay. So Y matrix is well defined matrix, and what they are saying that I1 is equivalent to what? 0.1 V1 minus 0.01 V2, and what is value of I2? I2 is 0.1 V1 plus 0.1 V2. This is Y parameter is given. What else is given? The else values are this. Just focus on this network and apply basic concept. If this current is I1, what is current coming from here? That current is also I1. So you can say the value of V1 is given by applied potential is 100 volt and 25 ohm into I1 is the potential drop. So V1 is what? 100 minus 25 I1. What else is given? If what the value of V2 is given. So you can say if this current is I2, what is current coming from here? This is also I2. So what is potential drop here? 100 times of I2. So you can say V2 equal to what? Because what is the polarity of V2? Plus to minus, and this is minus to plus. So you can say V2 is equivalent to minus 100 times of I2. Now what they are asking about the voltage gain. So let's talk about the voltage gain. Voltage gain means we are only interested in V1 and V2. So I can say the voltage gain is V2 divided by V1 ratio. Okay, let's calculate it. I2 equal to 0.1 I2 equal to 0.1 V1, and here I can write 0.1 into minus 100 times of I2. So you can say this is 11 times of I2 equal to 0.1 V1, or you can say I2 is equivalent to, or you can say 110 times of I2 equal to V1. Okay, fine. Fine, you can put this value here. V1, V2 is needed. What is not needed? I1 is not needed. So you can put this value here. V1 minus 100 minus V1 divided by 25. 100 minus V1 divided by 25 is I1. And I can put this value into equation number 1. So can I say 100 minus V1 divided by 25 is equivalent to 0.1 V1 minus 0.01 V2. In this whole equation, we are having V1, V2 and one constant is also there. We are interested in the V2 by I2 ratio. We are interested in V2 by I2 ratio. Okay. V2 equal to minus, okay, we can calculate it directly. Here is the thing. V2 is equivalent to minus 100 times of I2 and V1 is equivalent to 110 times of I2. So V2 divided by V1 is V2 is equivalent to this value is fine. And if I put this value here, let me do it again. I2 is equivalent to 0.1 V1 and 0.1 times of V2, and V2 can be written like this. So you can say this is 11 times of minus 10 plus 1. 11 times of I2 equal to 0.1 V1, and V1 can be 110 times of I2. So V2 divided by V1 is minus 100 divided by 110. So V2 divided by V1 ratio is minus 10 divided by 11, minus 1 divided by 11. I think one of the parameters is not correct here. That's why we are getting some different answer. But yes, this is the calculation. You can calculate the value of V2. Any parameter, any value you can calculate. This is simple mathematics. 1 KVL is applied here, 1 KVL is applied here, and using this 2 KVL you can find the final answer of this question. I hope you have understood this Y parameter. In next class we will talk about ABCD parameter and H parameter, and we will see how you can interconnect this ABCD parameter and A parameter, which is very important for exams also. Thank you very much.